Assalamualaikum and good evening. So please can you attendance accordingly based on the registered code. Okay. We'll start in another 3 minutes time. Okay, you can start scanning the attendance.
Kamu queue up or
Okay, then I'm going to disable the QR code right now. So those who are having scanned, so please do it right now. Okay, 3, 2, 1. Okay, I'm going to disable the QR code. Ready? Okay, can you see my slide right now?
Boleh, boleh, doktor.
Okay, so basically we're going to continue a little bit on the steering system and the rollover topic. So basically, this topic is all about a little bit on the function of the steering system and type of steering system. It's just that yeah, this steering, some of the steering topic we already covered in the handling topic. Okay, for this topic, we are looking at the application of the steering system in terms of how the power steering be used to improve the handling stability. Okay, they be it at low speed and high speed. Okay, where the end or the target of the vehicle handling is that the car will go in any direction that we want to go, be it at low speed and high speed, at affordable steering effort, okay, made by drivers. Okay, previously we do know that in passive steering system, so it can be either in apa, either the rack and pinion type of recirculating ball. So this type of steering system usually going to be the driver going to feel a bit heavy when want to steer the steering. Okay, and it just going just having disadvantage at low speed, but at high speed that stiffer steering effort for passive steering is basically going to help or assist in maintaining vehicle course or direction at very high speed. Okay, but with the power steering, with power steering, they used to assist the steering effort at low, be it at low speed and high speed. It's just that at low speed, what we call as power steering, either going to assist drivers steering effort at low speed, where at low speed drivers need to there's going to be less steering effort to steer tighter turn. So meaning, okay, the steering won't feel any heavy at all. While at high speed, this power steering is going to stiffen itself just to make sure that the vehicle don't go to left or right whenever there is no steering input from the driver. Okay, and then apart from the power steering, that functions are actually being extended to advanced features, which is we have active steering system, where active steering system involving the same function, the same component like the in this power steering. It's just that it's being controlled um, what to to steer the wheel without input from the driver. So meaning that whenever your vehicle, let's say for assume, let's say that there is a side wind pushing your car sideways, this active steering is going to recorrect itself without the drivers need to counter steer back the steering wheel. Okay, these features already being available in medium price car, like let's say for Honda HR-V. I think Proton, I know Proton don't have lane keep assist. Proton have lane warning departure on it, if I'm not mistaken. For X X90, X50, I'm not sure. Okay, but for Ford, okay, for Ford, and then there's many others with different names. But basically, this advanced or active steering system is actually based on power steering. Okay, power steering, and nowadays the power steering is based on electrical motor. Okay, a long time ago, when during the early introduction of power steering, manufacturers tends to use the hydraulic power steering because that time what the technology on the control algorithm for the electrical motor is not that as advanced as today. Okay, so they prefer to use a hydraulic power steering, which is even though that is bulky, it's much more easier to control it mechanically. Okay, but nowadays we have electric motor, so just install the electric motor to make some algorithm, pair it with the sensor. So when it detects low speed or high speed, so it's going to act accordingly. Okay, that's a brief for what we already learned in earlier. To move to the last topic, which is on tire. Okay, so can you hear my voice? Sorry, I need to pick up that call just now. Okay, okay. Now we're going to continue with topic. So we left at the wheel steer, all wheel steer. So basically, as you can refer to the YouTube, so all wheel steer means that all the wheels of the car can be steered. It's just that the amount of wheel steer angle is not the same. So meaning that usually, if the front steer, usually the front steer going to be more than the rear steer. Okay, and then it also depends the operation of the wheel steer. Either you're going to be in opposite direction or in the same direction. It depends on the speed. At low speed, the always steer going to steer in opposite direction so that you can have a tighter turn, as you can see in this rough sketch. And then at a very high speed, you're going the all steer always still going to steer in the same direction. It's just that the wheel steer angle is not the same. So it's just going to make the lane changing much more easier. Okay, it's just that for all wheel steer, now we don't this always here is not currently just is not a famous idea, because last I think this concept of always being introduced in mid 80s, and then until from 90s or 2000, early 2000, the concept is not being commercialized by manufacturer. It's not a famous concept, even okay, nowadays just already being applying. That one is also only on high end car. Okay, the reason is that it's too complicated and too expensive to apply to a normal vehicle. And then the same function, because the idea for always steer is that we want to have this one at a very high speed. It's going to ease the double lane change, or going to provide extra stability while maneuvering on the road. It's just that these features is actually available in ESC, ABS, and ABD. Okay, we now current system for a vehicle. Okay, and much more cheaper, because it only involve manipulation or apa or brake pad controls. Okay, compared to this one, it's just that for to have the same maneuvering stability like the all-wheel steer, the brake system need to be integrated with algorithm. So we have the ESC algorithm, we have the ABS algorithm, we have the EBD algorithm. Okay, that the combination of these algorithms actually can produce the same results as the always steer. Okay, it's just a minimum components plus with the control algorithm. That's it. Okay, it's going to perform like the always steer. Okay, it's just that it's just that it's going to be cheap compared to always steer, where this one is very expensive to apply to a car. So that's why you can see the always steer only being applied in high-end cars. So, for example, Audi, the one that you saw in the video. Okay. Okay, and then I would like to share another. I forgot to share about one interesting video also from YouTube. It's just that I didn't show you the what the keyword for that in YouTube. So this is another steering system also introduced by, I think by Bosch, if I'm not mistaken. So this one is a speed sensitive steering. So it's actually a type of power steering. So this one, speed sensitive, is what if I would like to draw the summation of the steering. So it's going to be like this. The saya tak buat slide view. Yeah, saya tunjuk ni dulu. So before to avoid from you confusing on this steering system, level of steering system. Okay, so basically, check this one first. So can you see my screen now?
Can, Doctor.
Okay. So basically, we have a level of steering system. So if I would like to make it the top down, so basically we have a passive steering. And then we have the power steering. And then later on we have the active steering system. Okay, if I want to say that for passive steering, we have two type of typical steering construction. We have rack and pinion. And then we have recirculating ball. Okay, and then this passive system, passive steering system, being converted into power steering, where in power steering, these two base type of steering system being coupled either with the electrical motor or hydraulic. Okay, hydraulic steering. So the same thing. Get back in opinion. So just write okay. So R and P D and RB. Okay, so this one RMP. So RB. So this RB, RMP, and RB can both be electric, or it can both be hydraulic. Same thing for this recirculating ball. It can be electric, and it can be hydraulic. Okay, now, okay, for the active system, so the same thing. We have the So this one is electric now. So I'm going to simplify this one as T, one as H. T, this one as H. So same thing for active. It's just that you're still going to use right antenna plus sorry, okay, electric or apa, hydraulic plus control algorithm, control system. So for right and pinion, resetting ball, you can have to either being assisted with electric or hydraulic plus with control system. Okay, understand? Understand? So any question on this level of steering system?
Okay, Doctor.
Okay. Okay. Now just that for electric vehicle or for the autonomous vehicle, usually yeah, be it they're going to come with any type of any kind any name that the manufacturer can give the name for the steering system in electric vehicle or in especially the autonomous vehicle. The type of steering system used in autonomous vehicle is this one. So this one is typical for autonomous vehicle. Okay, autonomous vehicle and EV. Okay, electric vehicle. This one for power steering, usually power steering electric vehicle, power steering. Yeah, usually for electric vehicle they're going to use this one, power steering. Okay, it's just that you need to differentiate because some of the vehicle or passenger vehicle, this one power steering, EV or power normal car. It's just that you need to know how to differentiate between because there are many types of names given by the OEM. So some of them name it lane keep assist and then lane departure warning. Okay, the one that really control your wheel tail angle whenever there is a side winds or uncontrollable motion of your car. So that one is what we call as the lane keep assist because lane for sure lane keep assist meaning that your car will always at all time be maintained to be at the center of the lane whenever there is no steering input from you. Okay, and another one is just we call it a lane keep lane warning departure. So that one is just warning system like a monitoring system to make sure that your car is at the center of the lane. So if it is not at the center of the lane, it's just going to give you a warning. It's just going to alarm you with sound, a beeping sound. Okay, but it will not auto correct the wheel steer. It's you that need to do the correction. Okay, so this is the level of steering system. Okay, and then for this one, speed sensitive steering under this one, power steering. Okay, so we have a different type of okay, different type. But for speed sensitive steering by Ford, by Bosch is fall under this category, power steering. Okay. Okay, this one, yeah, I'm going to share you some video from YouTube. Okay, this is the example of a speed-sensitive steering system made by Volvo. I think the supplier is Bosch, made by Bosch.
Hello everyone, welcome to this experiment for Volvo.
Today is the ultimate test of the steering system. You will see a hamster steering a truck from the bottom of this quarry to the top.
This environment looks beautiful, but it is very, very dangerous.
The hamster cannot look out the window, so we will have the driver, Sean, guide their hamster with a carrot.
Boy!
With the VDS system, it's very easy to steer. I can steer with my fingertips.
Hi Sean, it's Charlie. Good luck. Oh, and don't forget this, very important.
Okay, this one is actually using the award power steering. It's actually the way that is so light is that is using for commercial vehicle, for light truck they cannot use electrical motor. Usually they use the hydraulic pressurized hydraulic line. It's just that the opening of the valve for the hydraulic system is actually be controlled by the electrical signals from the steering system. So this electrical signal from the steering system is just going to control the openings of the orifice of the hydraulic system. So the more the wheel being steered, so the more the valve or the solenoid going to be open lah. So more pressurized fluid can go in, pushing the wheels to the left or to the right. So this one, okay, the way that if you see that the steering is too light, is actually there's nothing there. There's no actually load from the steering shaft. Okay, the steering just going to act like a potentiometer. Okay, like potentiometer is just when you rotate the potentiometer, so the voltage is going to be produced. Okay. So the same thing. So just they make same concept like potentiometer. So the steering is the potentiometer providing the electrical signals to the solenoid which control the hydraulic line. Okay. For this one, for this commercial truck, it is using the hydraulic pressurized hydraulic line, not electrical motor, because it's too big to use motor. If they use motor, they need to use very big electric motor and very high torque motor.
Okay, be careful, Sean.
Okay, this one is Volvo dynamic steering, but okay, this one is actually a Volvo dynamic steering, but basically it's actually a system that being supplied by Bosch. Okay, as you know, yeah, vehicle manufacturers, they don't really design the subsystem. It's actually the vendor. So most of the vendors like Bosch, like apa? There's another one. There's another company like ZF. Okay, Bosch, ZF, and then there's one company in Senai. Yeah, the company already being acquired by ZF. Previously is known by, if I'm not mistaken, apa saya tak ingat lah nama dia. Tapi that name is not famous lah. But instead it's actually been providing the standard vehicle dynamic modules, including ESC, ABD for the whole world market. Okay, and then ZF bought it, and then now it's actually under ZF. Okay, ZF is actually the most global vendor, most famous global vendor beside from Bosch, in providing a subsystem components to the vehicle, be it for passenger market or the commercial vehicle market. Okay, so now back to the our slide. So you can start looking for the keyword. You can start looking for the active steering, power steering from YouTube because there's a lot of video. Okay. Okay. Okay, that's it for the steering system. Okay, now we're going to take a look at the rollover. So basically, whenever we typically lah, when we control our steer our steering wheels and to control the direction of our car, especially at the corner, usually you're going to feel that the car tends to roll over, to have the tendency to roll outside, uh, or topple towards the outside direction of the car. Okay, and then this usually being prevented by anti-roll bar or stabilizer. Okay, and then also being assisted by the suspension stiffness. Okay, but the most the most system that contribute in roll prevention is actually the stabilizer bar. Okay, but if you are studying the roll prevention without the stabilizer bar, or we only consider that as the roll prevention is only be done by the suspension system. So we have two types of that suspension system that trying to prevent the rollover. The first one we call as a quasi-static rollover of a rigid vehicle, where we are studying about roll tendency while cornering by neglecting suspension deflection. It's not that the suspension is not there. It's actually we assume that we having a very stiff suspension system. Okay, it's like there is whenever there is at the corner, the car won't roll. Okay, assuming that there is no anti-roll bar. Second one is that we have a quasi-static rollover of suspended vehicle, meaning that when the car being or entering a corner, so basically there is going to be a roll, and then that roll will be prevented as best as possible by the suspension system. So it depends on the suspension stiffness. So if the suspension is stiff enough, so we can see less roll. If the suspension is too soft, and then we're going to see a lot of roll, but not up to the condition where the car will topple sideways. Okay. Okay, for this one, for the quasi-static rollover of rigid vehicle, usually, yes, we can see it in a real world for a racing car. Usually, for let's say for the drag race, like NASCAR racing in US, basically all of them are using. They have a suspension system. It's just that the suspension system is using a very stiff suspension setting. So meaning they have what hard spring stiffness or hard spring, and they have a hard shock absorber. Meaning that what I mean by hard is that when even though that the suspension be installed in the car, whenever you push down that corner, it won't affect at all. The car won't move. Okay, the car won't move down. The only thing that cause the car to move down when you press hard the corner of the car is because of the deflection of the tire. Okay, you need to remember the tire also act as spring, so that's the only source of the deflection. Other than that, your suspension system, the hard suspension, it won't it won't move at all because it's too stiff. Okay, this one usually typically being preferred by racing driver. Okay, the second one is just quasi-static rollover of suspended vehicle. This one is actually the rollover for a normal vehicle lah. Okay. So this is actually what happened. So it's already being simplified. So if you have apa? So this is actually the equation that already been summarized from Gillespie. So this is the equation where you can actually determine the if for quasi-static rollover of rigid, so meaning that there is no reflection. So the idea is that to get this one. Okay. to get this lateral acceleration. Okay, as you know, for a vehicle to be able to take a corner at very high speed, the lateral acceleration also need to be high, because virtually if okay, when vehicle, like I told you in previous topic, for in bicycle model, when a vehicle would like to take a corner, so basically there's going to be a virtual force that going to pull the car towards the inside direction of the car where you want to make a turn. Okay, so the higher the speed, so the higher the lateral force that you need to virtual force need to produce to pull the car in. So when that happens, so meaning that we also will have high lateral acceleration, or AY. And this suspension is this equation already summarize that. Okay, if you have the okay, if you have this one, so meaning that if you want, let's say that this one is actually the roll angle. Okay, this one is actually the roll angle. Yeah, roll angle in radian. So basically, if you want to have the what apa, if you want to have a high lateral acceleration, so this term roll angle need to apa, need to be very small. Okay, because this is a small value. Okay, being apa, being minus with this value, and then divided by this constant. So basically, you're going to have the very high value lah. Okay, very high acceleration. Okay, and then multiply by this g. So in case if this value is too small, okay, this value is too small, basically you're going to have this one approximately to zero. Okay, this one is constant. So if you have the mass, so basically this is going to be what the weight of the vehicle. So this one, this amount of lateral force divided by the amount of weight of the vehicle, usually this is actually going to produce a small value. Okay, small value multiplied by a constant of track width is actually can be summarized. This value is very small compared to plus with this one. Okay, so meaning that this term you can by having the roll angle is small due to there is no roll motion, so you can have this term very small. Okay, so meaning that you can maintain this one. So in the end, you can get the most optimal lateral acceleration based on this equation. So this is the so that's why for racing car, like let's say for drag car or like Le Mans racing, 24-hour Le Mans racing, to be able to take corner at very high speed. So this one another apa criteria lah. Okay. So later on you can see, because the behavior of corner taking a very high speed also being affected by the kinetic characteristic. This one very interesting. We're going to take a look later on in the next topic, last topic. Okay, now this is the same thing. So the same equation, but this one including the includes the roll from the deflection of the suspension. So this equation is still the same compared to the previous equation for the rigid body. So what we want is actually this one. So basically, you need to think something to get higher lateral acceleration. Okay, for that, you can only manipulate this one. Okay, this one rolling angle. Okay, and then also you need to manipulate the height of your CG and height of your roll center. So if let's say that you have a very small value over here, so then you can get a very small value for this term. Okay, and then in the end, overall, it's going to give you any small value. So in the end, it's going to give you a big value, and then it's going to give you high value. It's just that you need to know which parameters in this equation that need to be manipulated for high lateral acceleration. So that's one thing. Okay, that's it for the steering and rollover topic, with the last section which is on the quasi-static rollover of rigid bodies and suspended vehicles. So any questions on this topic? Any question?
No, doctor.
Okay, now okay, I'm going to share this topic with you. Okay, topic 8. Okay, I already shared with you the the updated slides on the steering and rollover topic. Okay, now we going to go to the new topic, which yeah, we're going to take some time on the mechanics of tire. Okay. Okay, I also shared with you the the slides on the last topic, which is on the tires topic. But that one, yeah, it's not updated. So you please download it first and just go through the slide because yeah, I'm going. I will be back in a few minutes time. Okay, bagi saya 5 minit. Okay, can you see my slide right now?
Can, Doctor.
Okay. So now we are at the last topic of mechanic of pneumatic tires. So basically, tires is actually the most complex system in the for vehicle, because in vehicle we have the most, if you look at in terms of the component, the engine construction has a lot of components. Okay, because there's a lot from radiator, starter, apa, alternator. Okay, the combination of this component itself already shows the complexity of engine's operation. But for tires, as we can see, it's just one single piece of rubber being molded to the shape of like the tire that we know. Okay. If for the engine, we do know its characteristic, but for tires, the characteristic can be changed depending on the condition itself. Okay, let's say that we have the tire, a new tire, and then 1 year use kind of tire, and then 2 years old tire, 3 years old tire, and 4 years old tire. Each years of tires, it won't have the same characteristic, because tire is made from rubber, and rubber tends to harden over time. Okay, the one usually for like for study, like the one that we use in handling modeling, where there is a tire model where for or tire force or lateral force estimation, we just use a constant, what we call as coherence stiffness, to represent the tire characteristic, where for certain angle of slip angle, there is what certain amount of lateral force or longitudinal force. It's just that is just estimation, whereas the actual characteristic is much more complex than that. Okay, and this complex characteristic is actually not being caused by the mechanical design. It's actually caused by the chemical compound used by the tire itself. Okay, and usually for in designing or analyzing vehicles, a new vehicle development made by the OEM, usually they're going to use, like I told you, for vehicle dynamics, they're using multi-body dynamic system simulation to study the vehicle behavior, where that vehicle model, the CAD model, be converted into the modeling multi-body model, where the model need to have very high accuracy, which is the percentage of error between the simulation result produced by that model with the experimental result, from the experiment, needs to be no more than 5%. So meaning that it's very accurate. So in terms of accuracy, this is the practice. So usually when it comes to designing thing where you need to design a system, first you design a simulation model, and then make it to experimental or physical model. Whenever you need to compare its performance, that performance between the simulation and experiment in industry, it need the percentage of error cannot be then more than 5%. Okay, if it is more than 5%, let's say that it still have 10%, and then you need to do something to make sure that you can increase or reduce the percentage of error. Usually, the accepted one that being practiced in industry is just 5%, which is the ones if you want to look into details, for those who are working with the result validation, they know lah how hard to get the result, the percentage of the result in terms of comparison between simulation and experiment, less than 5%. So a lot of work needs to be done. Even though that you can want to improve only 2 or 3% in terms of accuracy. Okay, back to the multi-body simulation model. Usually this kind of simulation model, they also use tire model. It's just that the tire model, they don't use the coherence influence constant. They have a non-linear characteristic of the tire. Okay, which later on we're going to take a look at that. Okay, this is just for introduction. Okay, now this is the overview of tire. So basically, for overall vehicle performance, it's actually being limited by the engine and the tire. Okay, this one you can see in the for normal vehicle, we cannot see that much, because we cannot accelerate on the road. We cannot drive that very fast on the road. But for Formula One team, this one is actually very important. So if you have a very powerful engine, okay, and you have a improper design tire, and then your powerful the power from your engine cannot be transferred effectively to the ground to propel your vehicle, because uh, if they have a poor selection of tire, basically that tire is going to sleep. Okay, that tire is going to sleep, or it's going to wear faster, and then because if the tire wear faster, the meaning that they need to stop regularly at the pit stop to change the tire. Okay, and then if they have let's say that also they have a very good tire, but if the engine also is not as powerful like the other top makers vehicle manufacturer in Formula One, same thing, they're still not going to win the race. So meaning that the vehicle performance for vehicle depending on these two types, okay, engine and tire. Okay. Okay, now this is the you can read the tire development from the slide. So basically, the original tire is just a start from wood, and then the vulcanization method being introduced before they start to introduce tire construction design, which is based on radial ply or cross ply, which we have today. So okay, this one kita akan tengok lah what is radial ply and what is cross ply. Okay, this is a tire cross section. Basically, if this is the code, so this is the one that I believe you already know how to read the code. So basically, this is the one. Okay, so if you have 195, this one is actually 195 mm. Okay, it's already being mentioned there in mm unit of tire width, and then this one is actually tire wall thickness. Thickness meaning percentage of this one, percentage of tire width. Okay. And then this one is actually the tire construction, either be it the radial construction or cross ply. So if it is a cross ply, you're going to write as mentioned as a C. Okay, tire construction. Okay, this one is the wheel diameter in inches. Okay, rim diameter in inches. Rim diameter. It's already been mentioned here. Okay, okay, tire width ratio, height ratio with 70% means that the thickness of the wall is about 70% from the tire width. The R stands for radial design or radial construction. Rim diameter is actually in inches. So if you want to calculate the what the tire radius, so you need to know this code, okay, which I already showed you how to calculate this tire turning radius in chapter 2, which is in the acceleration performance topic. Okay, this is already what explained before. So frontal width, this is for the frontal width or thickness. So this is actually 70% the tire sidewall thickness, 70% of the tire width, and then this is tire construction, and then this is the rim size in inches. Okay, so if you want to calculate the tire turning rolling radius, you need to standardize all the units. So this one is actually in mm, and this one is in inches. Okay. So be careful when you do the conversion, because yeah, this is actually a simple one, but a typical mistake that typically been done by students when calculating the tire rolling radius. Okay, this one is in mm. So this one is actually in inch. Okay, okay, cool. Okay, this is the size of tire contact patch as a function of tire profile. So basically, okay, size of tire contact patch is um, going to affect uh, your noise and VH level, your grip, okay, your grip function, tire grip function, as well as your rolling resistance, okay. And then if you take a look at the sum of tire pattern, be meant to stick towards the ground. Some of it used to repel water during rain, so that it's going to reduce what we call as aquaplaning effect. Okay, ni aquaplaning tu je saya just sharing lah. So what is aquaplaning? So meaning that aquaplaning is when your wheels step into step into a pothole, okay, and then step into a pothole filled with water, and then at that moment there is no contact between your tire surface and your ground, okay, and this condition is even though that it happens instantaneously, so it's going to be very dangerous because once your tire lose contact with the ground, you have tendency to skid, which skid can cause to accident. Okay, so if I want to draw this aquaplaning, so this is your aquaplaning. So let's say that this is your this is just a small amount of water, and then this is your tire. Okay, so whenever your tire you are driving at very high speed, so whenever your tire move on top of a small pothole or just a small amount of water, that even though that is just a thin just a thin layer of water on the surface, that one also can cause you aquaplaning, which causing you to have skidding. Okay, kalau macam ni kan, sebab ini this one is going to move very fast, so as if that tire is going to be like this. Okay, masuk dalam pothole, it's not going to be it's going to go into the pothole, but it's not going to really touch the bottom of the pothole. It's going to be able to move forward. It's just that during this moment there is no contact at all. So this is very dangerous because it can cause accident because they're going to skid, and then things going to get a very even dangerous if you have while you're driving your car in auto cruise mode or adaptive cruise control mode, because you need to remember whenever okay, let's say that you are turning on your or switching on your auto cruise function, so meaning that your car will always move at constant speed. Okay, let's say that when your wheels step into the pothole, and then it's going to skid. Okay, it's going to slip. So meaning that your tire is going to run and going to be slip. So you can see there is a water coming out. So this one, when the system detect this one, so the electronic system going to detect that there is a slip, okay, while you are in the pothole. So when you detect that, the system is going to increase the vehicle speed automatically. Okay, you need to remember that you are at very high speed. Actually, you don't need that high speed. And when your wheels goes out from this pothole, it is actually still in a very high speed mode. Okay, that is also dangerous because your system will suddenly first detect slip, which is unwanted slip. So the car is moving forward due to its momentum. And then going to reach this one, the next ground, next yang area where there is no pothole. So it's going to spin the wheels at very high speed. Okay, faster than you intended your car to go. So this one also can cause accident. So if your car, if there is another car in front of you, for sure there is going to be an accident. So for the safety features, for safety concern, usually we don't turn on the auto cruise function or adaptive cruise function during a raining condition, or you can see if there is a lot of pothole filled with water on the road. Okay, so this is some sealingan lah for the aquaplaning for tire. Okay, Now we're looking at the trade-off for tire development. So these are the elements that the tire designer needs to take a look at. So basically, you need to take a look at this straight head stability, steering precision, driving comfort, wet braking, core planning, the one that we talk about now, and then we have rolling resistance, durability, and mass. Okay, so these are so hold on. Okay, sorry for the disturbance malam-malam ni, ada yang call boss ni. Okay, okay, this one we go back at the trade-off at tire development. So usually in designing cars, so ideally we try to achieve every requirement that being shown in this slide. So we're going to have a straight ahead stability. We're going to have the tire that going to go in or going to assist our car to go in any direction that you want, which means we try to reduce the speed, the lateral speed of the car, and then also going to provide the driving comfort, meaning that there's going to be less noise in terms of non-vibration and harshness. And also we need the car to be able to assist in during wet braking, meaning that we during normal braking or emergency braking, so the car will stop faster. And also it's going to be less sensitive to aqua planning. Okay, and then also going to have less rolling resistance. So this rolling resistance is going to be affected by the tread pattern on the tire. So basically, tread pattern is the main element that is going to affect the rolling resistance, and then the wet braking, and then the driving comfort. And then usually we cannot achieve. This is actually the ideal ideal characteristic or ideal criteria that we would like to achieve. But usually we cannot achieve maximum for each of the criteria, because usually so that's why you have a wet tire, dry tire, and you have tires which are suitable to be used in both conditions. It's just that that kind of tire going to like in other criteria. For example, it's going to be very noisy. Okay, for example, it's not going to give you a good driving comfort. And then in terms of durability, for durability also they cannot we cannot design tire, even though the manufacturer can design tire which can last longer or more than 5 years, 4 years. So let's say for 10 years they can design it, but it's not good for their business. So basically, they're going to limit the life of the tire. So be it by the usage of tire itself, or by the natural hardening of the tire compound. So that's why you see the tire after 4 or 5 years, even though that is tire is never been used, being kept in store, that tire is not suitable to be used on road, because the rubber is actually quite hard. So when we're talking about hardening rubber, so usually at very high speed, it will have the tendency to burst, okay, which is very dangerous lah. Okay, not to mention the tires yang kita dah pakai, tire that we already have use at our car. Okay, after 4 or 5 years, it will have the tendency to burst if you don't change it. Okay, let's say that if you are you always travel far, and then it's okay, because after 4 or 5 years, the tire tread is usually going to wear, so automatically you're going to change the tire. But for those who are use their car for short distance travel, okay, just go to the grocery, buy groceries, go to semayang ke apa kan. So basically that tire, the tire pattern is going to be in good condition for a long time. Okay, sometimes can be still thick. The tire pattern still thick after 5 years time, but the tire itself is not in good condition where it's going to harden lah. Okay, the tire compound. Okay, now this is the tire composite. So it's actually made of steel, fabric, and rubber. So this fabric is actually the one that what you're going to it can be sometimes can be a wool fabric, things like that. Okay, and then the steel is actually the one that we lay on the tire, the one that going to determine the construction of type, either be it the radial ply or cross ply. Okay, this is the typical compound, and usually the one that going to effect tire characteristic is this one. So usually this is actually rest of the composition is just standard. What makes the tire special is this compound, and usually it being kept secret by the tire manufacturer. Okay, so they have their own recipe for their tire. Okay, this is design of radial tire. So in radial tire, everything the punya fabric, the rubber layer, and the steel is actually being laid in a radial position. But I say by radial position is it being laid like this, in this direction. Okay, this is radial from this point to this point, one layer, and then put another layer, this one. Okay, so this is actually the cross section where we have tread record, bed ply, bed cushion, swingy, macam mana nak pronounce ni? Okay, side strip, core, back core, ply, and tire shafting strip. So basically, okay, inilah kalau awak nak tanya saya yang detail, saya pun tak pernah kat cross section kan. So basically this is the basic construction. The one that is going to be different is actually this one, tire compound, which is the tread. The tread is actually most likely being it's actually a composition of manufacturer recipe. Okay, this is actually the one that going to determine the quality of the tire, either other than the tire pattern. So tire pattern is actually it can control it can control the NVH, and then water dispersion. So meaning that it's going to swipe out the water from underneath the tires towards sideways. So that's why if you see over here, this one is actually the a groove to swipe away the water towards outside direction of the tire. Okay, so that's the purpose of this strap, other than minimizing rolling resistance while at the same time providing tire grip. Okay, this is actually the this is the forces and torques at tire contact. So basically, same thing. We have a 3-axis system. longitudinal, lateral, vertical, and for each axis we have a moment or torque. Okay. Okay, the effect of the contact forces can be fully described by a vector of force and or torque or moment in a reference to a point in the contact point. So Z axis normal to the track, which is this one. X axis is perpendicular to the Z axis. This one is actually using the same steering approach, using the same axis system as we use for chassis. Okay, same thing. So the longitudinal or the x-axis is actually always pointing in forward direction, while the lateral axis or the y-axis also pointing out in towards out direction, while the vertical axis, the z-axis, always pointing upward. Okay. So Mx is the tilting torque. Basically, this one is the one that being generated from your suspension tilting or the camber angle. So rolling resistance, this one is actually being caused by when your tire is rolling, either being propelled or be provided torque from the engine, or the rear wheels just rotate following the front wheel. And then this one, MZ is actually the self-aligning and torque, ball torque. This one is actually the one that are going that is going to self-correct your steering system, because based on the suspension, camber angle, caster angle, kingpin angle. So that one is actually cause the self-aligning and ball torque. So this is the one that self-correct your wheels once you finish doing your turn. Okay, so usually when we do the turn, we just steer our wheels, and then when it is in the position of our U-turn or turning turn, usually we have the tendency to let go the steering wheel sikit-sikit lah. So you're going to do the self-correction. So that self-correction is actually being caused by this self-aligning torque. Okay. Okay, this is the side force generation. Okay, this is very interesting. Okay. Okay, ini pergi last and then we stop. Okay, this is actually the side force generation caused by slip. Okay, previously we already take a look at the lateral force equation. So this one is just a simplified one, whereas in the actual tire characteristic we don't use this one to estimate lateral force, because lateral force there are many other parameters value that we need to refer to, but this one is just estimating the tire lateral force based on slip angle, because we just looking at the generation of slip angle, how much our wheel being steered, and then based on that we can estimate the amount of forces that possibly pull our car sideways. Okay, previously okay, we have the okay, in bicycle model we have this one, Fy, the dimension of Fy equal to MAY, right? So this one we are talking about the lateral dynamics only. Okay, and then this Y we have the frontal lateral force. We have the F lateral for front plus F lateral for rear axle equal to MAY, with F lateral equal to cornering stiffness, this one. Okay, multiply with alpha cornering, okay, cornering stiffness. Okay, from CF, I put the CF. Okay, slip angle. Okay, okay. This constant is actually being obtained from this graph. This constant, cornering stiffness, is actually came from this one. Okay, so basically Okay, there is a if you take a look at the there is a rate, experimental rate used to determine or to measure the amount of lateral force based on the wheel's slip angle, meaning that like I told you in bicycle model, okay, there is two difference. We have the wheel steer angle, and then we have the slip angle. Where wheel steer angle is actually the angle that we want our car to go, the direction that we want that our car to go. But towards going towards that direction, the wheels is not only the wheel will slip, so meaning that there's going to be a small deviation, okay, before it reach the final slip angle. So that slip angle is actually this one, okay. Okay, ini kita ada dua. So basically kita akan ada, this is slip angle. So right now, okay, in this figure we're looking at alpha equal to this one lah. But ideally, okay, ideally we want, ini just ignore. So ideally, the ideal condition that the one that we want is that we want this is the wheel steer angle. This is the ideal condition or the exact direction that we want to go. But due to the condition of the wheel, road condition, sometimes the car will only go into this direction. Okay. So this is the slip. So this is the V. So this is the slip. Okay. So this is the amount that amount of force that needs to be generated for the wheel to go into the intended direction. Okay. In this figure, we are assuming that alpha or slip angle equal to the wheel steer angle. Okay. Okay. Based on this graph, so you can see that this is the constant. So it's going to increase proportionally. So that's why we use this constant cornering stiffness. Okay, so for certain angle of slip angle, so there is going to be high lateral force. Okay, but what happens when you have what does it mean by high slip angle? Let's say that this one up to 14, and then let's say that we have 14 or 14 degrees. Okay, so meaning that we're going to extrapolate this graph up to here. Okay, so there is no such thing of a bigger slip angle up to 14 or 15. Okay, because usually when it means we like this one slip, yeah, you know slip lah. Okay, it will not go into direction, so that is slip. So meaning that if you have a higher slip angle, meaning that your car is actually in a drift condition, okay, drift mode. Okay, macam drifting lah. So awak tengok tu. So that's why awak tengok dalam kereta drift, walaupun tayar dia macam slip kan, lateral sideways, but the car still can go into make a corner or making a turn because of this characteristic. But it still need to be controlled lah, so by the driver. So this is side force generation caused by slip. So ini kita ada side force. Okay. This one is a side force. Lateral force, side force is going to be equal because action and reaction, Newton's law. Okay, this one is lateral velocity. This one is the longitudinal velocity, and then this one is the slip angle. Where for this figure, we are assuming that slip angle is equal to wheel steer angle, meaning that it's the ideal condition yang dia akan achieve lah, meaning that if we kita nak pergi, we want to go towards a certain direction, we need to steer 5 degree, but the cars will go also 5 degree. So that means that the slip angle is 5 degree lah compared to this one. So ini kita nak pergi arah 5, tapi kereta sebenarnya steer tak sampai 5 pun. So the rest of this one yang balance tu yang sampai, so that one is the slip angle. Okay, but ideally yang kita nak kita assume lah, so slip angle equal to steer angle. Okay, so that's why we can assume this one. So we can say that side force is equal to lateral force, which is being given by this one, cornering stiffness and slip angle gain from this graph. Okay. Okay, this experimental rate that they use to to conduct the experiment to characterize the tire characteristic. Okay, uh, for this one, for lateral force versus the tip angle, this you can Google it yourself by looking for the keyword tire characterization test rig. Okay, using tire characterization test rig. So where you can see the test rig being conducted in lab, where they put one tire run by AC motor. So once the tire keep on rolling on the track, they will steer the whole assembly of tire and the motor, so that they're going to have the tires being steered on the treadmill. Okay, so during that motion, you can see that the tire going to deflect like this. Okay, you can see that it's very interesting. And then that machine itself is very expensive. So usually, even in Malaysia, we don't tire manufacturer don't have that kind of machine, because usually it's going to only available in the headquarters tire manufacturers headquarters, which has the R&D department. Okay, in Malaysia, for tire manufacturers like Toyo Tires, Bridgestone, they do have the manufacturing plant in Malaysia, but they don't have this kind of machine, because the one that they have in Malaysia is just for the tire quality check. Okay, not for the characterization which involved in the tire R&D. Okay, and then usually the characterization done by this machine, tire characterization test rig, is actually very expensive, and usually it will be used by the tire manufacturer itself, and also being used by the vehicle manufacturers in their multi-body simulation. And usually when the vehicle manufacturers want to get this data from tire manufacturers, the tire manufacturers they do not give it for free. The vehicle manufacturers vehicle OEM need to purchase that data from the tire manufacturers. Okay, and then that data is very expensive. Like the last time when I was at Proton, where they are been doing development on the Proton Persona, where they want to simulate the Proton Persona, either they're going to pass their characterization performance for the vehicle dynamics. They're using actual data characteristic which they get from this machine, and the data is actually being they got it from I think from Europe, and then it costs one set of data about 40,000 ringgit. Okay, very expensive. So yeah, we don't have that machine, because that machine is alone is very expensive. So if they want the data, they need to purchase it, just the data, to ensure that the vehicle model is very accurate. Okay, so they need to that's towards their accuracy of the model. So they are Proton that time when they're doing the R&D, they're willing to pay uh, for that amount of money for the data to ensure the accuracy of the model. Okay, I'm going to stop now, because so we're going to continue next week. So far, any questions on the tire topic? Hopefully we can finish this one next week. So if there is no question, we can dismiss.
Thank you, Doctor.
Yeah, thank you.
Thank you, Doctor.
Thank you. Good night.